Welcome students for this online lecture. Today we are starting the last chapter, rotational motion. Students, we know that there are two types of motions. One is translational motion and another is rotational motion. The translational motion of the system, we know that in the system there are number of particles. And in a translational motion, every particle in the system in a translational motion, every particle in the system, every particle in the system undergoes same displacement in same interval of time, same time interval. Then the motion is said to be translational motion. That is, every particle in the system undergoes same displacement in same interval of time. Then the motion is said to be translational motion. Or if the particle goes from one position to another, that means the position coordinates. Initially, the coordinates are x, y, z. After time dt, the coordinates are x1, y1, z1. Then the system is said to be in translational motion. That is, every particle in system undergoes some displacement, linear displacement in time interval. Then the particle is said to be in to have a translational motion. किंवा system of particle असेल तर every particle in the system undergoes same displacement in same interval of time. Then the system is said to be in translational motion. And second is rotational motion. Rotational motion means every particle, the motion of every particle is in motion, but the motion of every particle describes a circle like this. Every displacement of every particle describes a circle whose center lie along a line. The motion of particle describes a circle whose center lies on the axis, and that axis that is called as axis of rotation. This is rotational motion. Now here in linear displacement, in translational motion, we use the term linear velocity. That is rate of change of displacement with respect to time. That is linear velocity. And in rotational motion, we use the term angular velocity. Angular velocity means rate of change of angular displacement in time with respect to time. That is d omega upon omega equal to d theta upon dt. This is angular displacement dt, d theta, and it takes place in time dt. Then angular speed is d theta upon dt. Then here we use the term linear acceleration. Here we use the term angular acceleration. Linear acceleration, it is dv by dt, and angular acceleration, it is rate of change of angular displacement. That is angular velocity, sorry, not angular displacement, angular velocity, that is rate of change of angular velocity, angular acceleration. Then we use the term force in a case of translational motion. And this force, it is given by mass into acceleration according to Newton's second law of motion. And here we use the term torque. And torque in rotational motion that produces this angular acceleration. Force in translational motion that produces linear acceleration A Here torque is in a rotational motion, it produces the angular acceleration alpha, and it is given by T equal to I alpha. Angular velocity. We know angular velocity, that is the rate of change of angular displacement with respect to time. Rate of change of angular displacement with respect to time, that is angular acceleration. Now, in angular acceleration, we know that every particle in the system, the motion of every particle in the system, it describes a circular path, and the center of the circle lies on the single line. Center of the circle, the motion of every particle in the system, it describes a circle, and the center of circle lies on a line. Then the body is said to be in rotational motion. Here the body is rotating about this. We consider a body, this is rotating in this direction, in anti-clockwise direction, about z axis. And every particle in the body, motion of every particle in the body, it describes a circle of radius r, like this. Suppose the particle makes angular displacement d theta when it displaced from a dash to b dash in small interval, time interval dt. So आपण instead of d theta we use dou theta in time dou t. Then the angular displacement, we can write like this: the angular displacement a dash b dash, that is equal to r into dou theta. A dash b dash, arc, this is r, so radius into angle, that is r d theta. This is the angular displacement of the particle. And ds, AB dash, this is ds. ds means linear displacement of the particle, and angular displacement of the particle in the system, it is r d theta. Angular displacement is vector quantity, and the direction of this angular displacement, it is given by right hand rule. That is, fold the fingers of right hand in the direction of motion of particle. Fold the fingers in the direction of motion of particles. Then the stretched thumb gives you, stretched thumb means this stretched thumb, that gives you the direction of angular displacement. So this will be the direction of angular displacement d theta. Angular displacements are d theta. Now the instantaneous angular velocity omega, this can be rate of change of angular displacement, and it can be given like this: is at that instant dou t tends to 0, rate of change of angular displacement, that is dou theta upon dou t. And the unit of this, or we can write like this, that is equal to d theta upon dt. This is instantaneous angular velocity. The unit of angular velocity here, angular velocity, rate of change of angular displacement per second. The angular acceleration means rate of change of angular velocity, that is angular acceleration it is denoted by alpha, and we can write it as like this. Angular acceleration, rate of change of angular velocity, dou t tends to 0, dou omega upon dou t. Or we can write like this, it is d omega upon dt. This is angular acceleration, rate of change of angular displacement. And the unit of angular acceleration, it is per second square, because it is per second. Omega, unit of omega is per second divided by second, so it is per second square. Angular displacement, angular velocity, angular acceleration, all these are vector quantities. Angular displacement, I told you what is angular displacement. Angular velocity, omega, rate of change of angular velocity, and rate of change of angular displacement means velocity, and rate of change of angular velocity means angular acceleration. All these are vector quantities, and the directions of these angular velocity, angular displacement, all these are given by right hand screw rule, right hand rule. These vectors are along the direction perpendicular to the plane of rotation, that is given by right hand thumb rule. That is, the direction of rotation of the system is curl your fingers along the direction of rotation of system. Then the thumb will represent the direction of angular displacement, direction of angular velocity, and direction of angular acceleration. So the direction of angular displacement, the direction of angular velocity, and the direction of angular acceleration, it is perpendicular to the plane of rotation of the particle. Then we will see angular momentum. Now we'll see angular momentum. Angular momentum is a useful concept in rotational motion. Just like in linear motion, we use the term linear momentum. Suppose a particle is having rotational motion like this. It is rotating about this axis of rotation, and m be the mass of the particle, and the particle has linear velocity v. So the linear momentum, the particle has linear momentum mv, and at this instant, if the velocity is v, then the linear momentum is mv along this direction. Then the angular momentum, it is given like this. It is L equal to R cross P, where the part R is the position vector of the particle from origin O. So this angular momentum, it is given by vector R cross vector P. Or we can write like this, R equal to, we know cross product. If angle between R and P is theta, then we can write like this, R P sine theta. That is equal to R P sine theta. And R, that will be R sine theta into P. And we know that R sine theta, always R sine theta, it is a perpendicular distance of R from the line of action, that is P, and it is called as moment R. So angular momentum is also defined as moment of momentum. याला असंही म्हणतात moment of momentum. The angular momentum L, it is R cross P, and or we can write like this, RP sine theta. If theta is angle between R and P, then it is RP sine theta, and it is also called as moment of momentum. Now, if we consider a rigid body means in a body distance between two particles is fixed, then the body is said to be rigid body. And suppose in the rigid body there are a number of particles, and rigid body is rotating with angular velocity omega. Suppose this is rigid body, it is rotating about this axis with angular velocity omega. Then suppose in the body there are number of particles having masses, number of particles having masses m1, m2, dot 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 up to mn. Perpendicular distances of that points masses from the axis of rotation. Suppose m1, r1, r2 up to rn. v1, v2, v3 are the linear speeds of the particles. Then the angular speeds, linear speeds are v1, like this. v1 equal to r1 omega, we know. r2 omega, v3 equal to r3 omega. Then L, angular momentum, it is given by summation of Li, that is L1 plus L2 plus L3 dot dot dot, like this. आणि L1 म्हणजे काय असेल? R1 P1 plus R2 P2 plus R3 P3 dash dash dash. आणि R1 P1 माहिती आहे आपल्याला, P1 सॉरी नॉट R1 P1, R1 P1 बरोबर R1 into P1 means M1 V1 plus R2 P2 म्हणजे काय असेल? M2 V2 plus R3 M3 V3. But we know that V1 equal to R1 omega, so R1 M1 R1 omega plus R2 M2 R2 omega plus R3 M3 काय असेल? R3 omega. म्हणजेच तुम्हाला टोटल लिनियर मोमेंटम ऑफ ए रिजिड बॉडी that is equal to काय असेल? M1 R1 square omega plus M2 R2 square omega plus M3 म्हणजेच we can write like this: omega into M1 R1 square plus M2 R2 square dot dot dot. That is, we can write like this: omega into summation of mi ri square, I runs from 1 to n, and summation of m